So in this video, let us look at the definitions of trigonometric functions. So in your lower classes, you have seen what trigonometric ratios are. Trigonometric ratios. So you have seen that you have 6 trigonometric ratios. Sin theta, cos theta, right? Tan theta, cot theta, secant theta, cosecant theta. In your lower classes, you have read these as trigonometric ratios. Now, you're looking at what are called trigonometric functions. So we have already seen the topic of functions. What is a function? A function is a machine which takes in certain values and gives out the answers. A function is a machine which takes in certain numbers and gives out certain answers. It's a relation. It's a rule connecting x with y. That is what a function is. Now, in 11th class, we are going to define these trigonometric ratios as functions. That is, I'll define a function y is equal to sin x, y is equal to cos x, so on. And these are functions which takes in certain angles and gives out the answers. Now, what is the definition of sin x? If I want sin x, what is the definition? In your lower classes, what you have done is you have drawn a triangle. You have drawn a right angle triangle whose angle, one of the acute angle is x. And once you draw this triangle, the opposite side by hypotenuse is the value of sin x. This definition is valid only for acute angles. This definition is valid only for acute angles. Now we are going to see the definition which works for all the angles. Acute, obtuse, negative angles, whatever are the angles, these definitions work. So what is the definition of sin x? So if you want sin x, what you need to do is, or sin theta, so let us say this as sin theta. If you want sine of certain angle, what you need to do is you need to rotate this initial ray through an angle of theta. So whatever is the angle that is going inside this machine, you just need to rotate the initial ray through that angle. Now on this ray, you take some point P, any point can be taken, some point P, let the coordinates be x comma y. Let the coordinates of this point be x and y. And let the distance of this point P from origin be equal to r. So let us rotate the initial ray through an angle of theta degrees, right? And you get the terminal ray. On this terminal ray, take any point P, x comma y, and the distance of this point P from origin is r. Then sin theta is defined as y by r. That is the y coordinate of this point by r. So that's the definition of sin theta. Similarly, cos theta is defined as the x coordinate by r. That is x by r. And tan theta is defined as the y coordinate of this point by x coordinate of this point, y by x. So now there is no triangle. You don't need a triangle. So whenever you want to find sine of certain angle, you just rotate the ray through that much angle, take any point P on that line, and let the distance of the point from the origin be equal to r. You have some x coordinate, you have some y coordinate, and y coordinate by r is sin theta, x coordinate by r is cos theta, y coordinate by x coordinate is tan theta. Similarly, cosecant theta is defined as the reciprocal of sin theta, r by y. Secant theta is defined as r by x, and cot theta is defined as x by y. So these are the definitions of the trigonometric functions. So now, once these definitions are taken, so you can think of trigonometric ratios as functions which take in the values of angles, which takes in angles and gives out the value of trigonometric ratios. And once we have understood the definitions of trigonometric ratios or trigonometric functions, we can talk about the signs of trigonometric functions in different quadrants. So now let us say that you need to calculate sine of some angle x. So what you do is you rotate this ray, you rotate the ray from the initial position through an angle of x, and wherever the ray stops, if the ray stops in the first quadrant, then we say that the angle is in first quadrant. So if the ray stops in the second quadrant, so sometimes if x is something like 100 degrees or 110 degrees, if you rotate the ray through 120 degrees, we know that the ray stops in the second quadrant. So if the ray stops in the second quadrant, then we say that that particular angle is in the second quadrant. Similarly, if the ray stops in the third quadrant, then the angle is in the third quadrant. If the ray stops in the fourth quadrant, then we say that the angle is in the fourth quadrant. Now first, let us say that the angle is in first quadrant. Whatever is theta is in the first quadrant. That means once you rotate the ray through an angle theta, the ray stops in the first quadrant. Now in the first quadrant, if you see, both the coordinates of any point on this line are positive, right? In the first quadrant, both the x coordinate and y coordinate are positive. So y by r is the distance from origin to the point. Obviously distance is always positive. So what is the sign of y by r? Will y by r be positive or negative? Y is a positive number, r is always positive. So positive by positive is positive. Similarly, the value of cos is plus by plus. The value of cos is also positive. And the value of tan, which is y coordinate by x coordinate, plus plus, both are positive. And positive by positive is positive. That means if the angle is in the first quadrant, that is, if the ray stops in the first quadrant, all the trigonometric ratios are positive. If sine is positive, correspondingly cosecant will also be positive, because cosecant is the reciprocal. Cos positive implies secant is also positive. Tan is positive implies cot is positive. All the ratios are positive. Now if you go to the second quadrant, so if you take any point on this ray, so we know that the x coordinate of this point will be negative and the y coordinate will be positive. And the distance of this point P from origin will always be positive, because distance is always positive. So if you calculate the trigonometric ratios, so sine is y coordinate by r. Y coordinate is positive, by r is positive, so sine is positive. What is cos? X coordinate by r, x is negative, r is positive. So negative by positive is negative. Similarly, tan is y coordinate by x coordinate. Positive by negative is negative. That is, in the second quadrant, sine is positive, cos and tan are negative. If sine is positive, cosecant is also positive. Cos is negative, secant is negative. Tan is negative, cot is negative. So that's why I'm not writing the reciprocals, because if the function is positive, the reciprocal will also be positive. Function is negative implies the reciprocal is also negative. Now if you go to the third quadrant, so if you take any point P on this ray, both the coordinates will be negative, right? Because in the third quadrant, both x and y are negative. R is always positive. So y by r, negative by positive is negative. Cos x by r, negative by positive is negative. Tan is y by x, negative by negative. Both the negative signs gets cancelled, you get a positive number. So tan is positive in the third quadrant. Now if you go to the last quadrant, fourth quadrant. So if you take any point P on this ray, the x coordinate will be positive and the y coordinate will be negative. So sine is y coordinate by r, negative by positive, sine is negative. Cos is x coordinate by r, x is positive, r is positive. Positive by positive is positive. And tan is y by x, negative by positive is negative. So these are the signs of trigonometric ratios in all the four quadrants. So now you need to remember this very carefully. But if you want to remember all these 12, it will be difficult to remember. So the shortcut to remember this signs is ASTC rule. ASTC rule. So you can remember this as after school to college. So ASTC rule, after school to college rule. So A means in the first quadrant all the trigonometric ratios are positive. In the first quadrant all trigonometric ratios are positive. In the second quadrant sign is positive and the remaining two are negative. So I am only dealing with these three ratios. So corresponding reciprocals can be obtained by you. So in the second quadrant sign is positive. That means the remaining are negative. In the third quadrant tan is positive and the remaining ratios are negative. And in the fourth quadrant C, cos is positive and the remaining ratios are negative. All sin, tan, cos, ASTC, after school to college. So after school to college, ASTC gives you the positive ratios in different quadrants. In the first quadrant all are positive. In the second quadrant sin is positive, cos and tan are negative. In the third quadrant tan is positive, sin and cos are negative. In the fourth quadrant cos is positive, sin and tan are negative. So these are the signs of trigonometric ratios in the four quadrants. Let us try to practice this. So for example, so let us deal with this question. You're asked to find the signs of these ratios. So you're not asked to find the values of this. You're just asked to see whether these numbers will be positive or negative. Sine of 403 degrees. To investigate the sign of this trigonometric ratio, so we need to understand in which quadrant this angle lies. So what we do is we take the coordinate system and we start rotating the ray. So all these angles are positive if you see. So we are going to rotate in counterclockwise direction. So now if you want sine 403, you need to rotate the ray through 403 degrees. So let us start rotating. This is a 0 degrees. So when the ray comes here, you get 90 degrees. When the ray enters this, when the ray coincides with this, you get 180 degrees. And as the ray rotates, you get 270 degrees here, because each of these are placed at 90 degrees apart from each other. One complete rotation gives you 360 degrees. And then if you go on rotating still more, you go on getting different angles. 360, 450, 540, again 90 degrees, 630, and two rotations gives you 720 degrees. And if you go on rotating them still further, 810 degrees, 810 degrees, 900 degrees, 990 degrees, 1080 degrees, so on, the rotation happens and the angle goes on increasing. Now if you go for sine 403, so where does 403 lie? So 403 lies somewhere in between 360 and 450, right? Lies somewhere in between 360 and 450. So if the ray rotates through 403 degrees, let us say that the ray is rotating like this, it covers 360 plus 43 degrees extra. So 360 plus 43 extra, the ray stops somewhere here. So for the first question, the ray stops somewhere here. Hence, this angle lies in first quadrant, and in the first quadrant all the ratios are positive. So sine 403 is positive. Good. Next, let us go for cos 158 degrees. So where does 158 lie? So if you go on, if you start rotating the ray, okay, from 0 it goes 90 and here it becomes 180. As you can see, 158 lies between 90 and 180, right? So 158, if a ray rotates, it will stop somewhere here. So the ray is in second quadrant. In second quadrant, just remember ASTC rule. In the second quadrant, sine is positive. That means cos and tan are negative. So cos is negative. So in the second quadrant, cos is negative. So cos 158 degrees will be a negative number. Next, tan of 923 degrees. So you should try to understand where 923 lie. So as you can see, if you take one rotation 360 degrees, if you complete two rotations, you complete 720 degrees and 810 degrees, 900 degrees, 2.5 rotations and 23 degrees extra. So if you rotate the ray through 923 degrees, it will stop in third quadrant. And in third quadrant, tan is positive. So tan 923 is a positive number. Next, cot 795 degrees. So you should see where 795 degrees lie. So as you can see, 2 complete rotations gives you 720 degrees. 2 complete rotations gives you 720 degrees. And the 795 lies between 720 and 810. So this 795 is 2 rotations plus some acute angle. So it will lie somewhere in the first quadrant. In the first quadrant, cot is positive. So let's go to 1283. So as you go on calculating this, so you can go on writing the numbers increasing in each step by 90 degrees. Otherwise, what you can do is, you can see how many 90s are there in this 128. So 1283 divided by 90. So you can just see how many 90s are. So ones are 90. So you have 38 remaining, 383. So 94s are 360, and you have an extra 23 degrees. So 1283 is nothing but 14 times 90 degrees, 14 right angles plus some acute angle. So let us draw a fresh diagram. So if you go through 14 90 degrees, 14 right angles. So you have 4 right angles here. One more rotation gives you 8 right angles. One more rotation gives you something like 12 rotation, 12 90 degrees, 12 right angles. So 13 right angles, 14 right angles plus some acute angle. So the ray stops in the third quadrant. So in the third quadrant, we know that tan is positive. So if tan is positive, that means cot is positive. Sine and cos are negative. So if sine and cos are negative, correspondingly cosecant and secant are also negative. So secant is negative. So similarly, if you want cosecant of 2574, we do the same thing. That is, we'll see how many 90s are there in 2574. So let us divide this. So 2574 divided by 90. So 92s are 180. 92s are 180. So you have 77 for 774. So 90 into 8s are 720, and you have an extra 54 degrees. So that means 2574 has 28 right angles plus some acute angle. So if you go for 28 right angles, so as you can see, 28 is a multiple of 4. 28 is a multiple of 4. So that is 4 rotations. 4 right angles gives you 1 complete rotation. So 28 right angles gives you 7 complete rotations. So you have 7 complete rotations plus some acute angle 54. So 7 complete rotations brings the ray back to the original position plus 54 degrees. From here you are going 54 degrees extra. So the ray obviously stops in the first quadrant. So in the first quadrant, all signs are positive. So cosecant is also positive. So I hope you have understood how we decide the signs of the trigonometric ratios. Thank you.